Cluster Federation is a powerful approach to managing multiple Kubernetes clusters through a unified control plane. In this video, we'll explore how Federation enables you to manage resources across clusters from a single point of control, making multi-cluster management significantly simpler and more efficient. Cluster Federation allows you to manage multiple Kubernetes clusters across different environments using a single control plane. Think of it as having one central dashboard to control all your clusters, regardless of where they're running. The Federation system synchronizes configurations, policies, and resources across all your clusters automatically. What makes this especially valuable is that you get centralized management without sacrificing the independence of each individual cluster. Each cluster can still operate on its own, but they're all coordinated through the Federation control plane. Federation provides several important benefits for organizations. First, it enables multi-region support, allowing you to deploy applications across different geographic regions for high availability and disaster recovery. Second, it's multi-cloud ready, meaning you can manage clusters across Amazon Web Services, Microsoft Azure, Google Cloud Platform, and even on-premises infrastructure from one centralized location. Third, it simplifies operations by providing unified resource management and consistent policies across all clusters. Finally, it enables intelligent load distribution, automatically spreading workloads across clusters based on their capacity and geographic location. The architecture of Cluster Federation follows a hub-and-spoke model. At the center, you have the control plane, which acts as the central management layer. This control plane connects to multiple member clusters, which can be running on different cloud providers. For example, you might have Cluster A running on Amazon Web Services, Cluster B on Microsoft Azure, and Cluster C on Google Cloud Platform. The control plane communicates with all these clusters, propagating configurations and collecting status information from each one. This architecture ensures that all clusters stay synchronized while maintaining their individual autonomy. Cluster Federation consists of three core components. First is the Federation control plane, which serves as the central management layer that orchestrates all federated clusters. Second is the KubeFed API, which extends the standard Kubernetes API to support federated resources and configurations. This API layer allows you to define resources once and deploy them across multiple clusters. Third is the Propagation controller, which is responsible for distributing resources and policies to member clusters automatically. These three components work together to provide seamless multi-cluster management. Let's look at a practical example of a federated resource. A federated deployment is defined using a YAML manifest that specifies which clusters should receive the deployment. The API version is types.kubeft.io/v1beta1, and the kind is federated deployment. In the metadata section, you define the name and namespace. The crucial part is the spec section, where you specify the placement. Here, you list the clusters where this deployment should be created. In this example, we're targeting cluster-A and cluster-B. When you apply this manifest to the Federation control plane, it automatically propagates the deployment to both specified clusters. Federation offers several placement strategies to control where your resources are deployed. Cluster selection allows you to explicitly specify which clusters should receive the federated resource by name. Label matching enables you to use cluster labels to dynamically select target clusters based on specific criteria, such as environment type or region. Weighted distribution lets you assign different replica counts to different clusters based on their capacity or priority, ensuring optimal resource utilization. Finally, cluster exclusion allows you to define which clusters should not receive specific resources, giving you fine-grained control over your deployments. Resource synchronization is a critical aspect of Cluster Federation. The process involves three main activities. First is template propagation, where the control plane pushes resource templates to all target clusters. This ensures that every cluster receives the correct configuration. Second is status collection, where member clusters continuously report the status of their resources back to the Federation control plane. This allows you to monitor the health and state of resources across all clusters from a single location. Third is policy enforcement, which ensures that security and compliance policies remain consistent across all clusters. This three-way synchronization keeps your entire federation in a consistent state. Cluster federation is particularly valuable in several scenarios. For global applications, you can deploy services across multiple geographic regions to provide low-latency access to users worldwide. For disaster recovery, you can maintain backup clusters in different regions to ensure business continuity if one region experiences an outage. For data sovereignty requirements, Federation allows you to keep data within specific geographic boundaries while still managing everything centrally. Finally, for burst workloads, you can scale applications across multiple clusters during traffic spikes or periods of high demand, ensuring your applications can handle peak loads efficiently. While cluster federation offers many benefits, there are challenges to be aware of. Network latency between clusters can impact synchronization speed and application performance. The system also introduces increased operational complexity compared to managing a single cluster. Resource synchronization overhead can consume network bandwidth and processing resources. To address these challenges, follow best practices. Start with simple use cases first before tackling complex scenarios. Monitor the health of your federation control plane continuously to detect issues early. Finally, test failover scenarios regularly to ensure your disaster recovery plans actually work when needed. By understanding both the benefits and challenges, you can make informed decisions about implementing cluster federation in your environment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.